It's fair to say that it's time to get serious because midterm examination's coming up soon. So what I want to do, I've prepared a midterm study guide. I'm not really sure how many problems. I think there are 10 problems. Let me see. No, actually there are 12 problems. But some of the problems have multiple parts, so I'd say there's going to be close to 20 problems. So it's going to be kind of a long video, I do think, but it's going to be an extremely important video because it's going to summarize some of the things that I want you to know for your midterm. So let's just go ahead and get started here. I don't have my my glasses on, which could be a disaster, but let's see. So just example questions. Number one is to classify the following distribution as bell-shaped and symmetric, positively or negatively skewed. What measures of central tendency and variability would be appropriate to describe this data set? Guys, you're definitely going to have something like that on your exam. The first, if we smooth this out, we can see that we have what's called a tail in a distribution. And whichever way the tail goes defines the shape of the distribution if it's skewed. Now what I mean by that is you got to think about these graphs are all embedded in an XY coordinate system. And numbers to the right are positive, numbers to the left are negative. So we have positive 1, positive 2, positive 3, negative 1, negative 2, negative 3. So our negative numbers are over here, positive over here, obviously. Now, when your tail is going to the right, as we have in this situation right here, then we have what's called a positively skewed distribution. If we had a distribution that looked like this, where the tail was going to the left, then that's going toward the negative numbers. It'd help if I get my big old fat hand out of the way, wouldn't it? The tail's going toward the negative numbers, so that would be a negatively skewed distribution. So guys, what we have here, because the tail is going to the right, we have a positively skewed distribution. And some characteristics of a positively skewed distribution. The mean will always be greater than the median. And the measures of center and spread that we would depend on would be the median and quartiles. Now the quartiles could be, using the IQR, but you want to use some measure of spread that's built around the center, and since we're using the median as the center, you would use the quartiles. Remember, the quartiles are built around the median as a measure of spread, and the standard deviation is built around the mean as a measure of spread. Now, the reason we use the median as a measure of center here is it's not as affected by outliers as is the mean. And I can just give you a simple illustration on that. Let's say we just had the numbers 1, 3, 3, 5, 5, 5, 7, 7, 9. And if you put those values in your calculator and did a histogram, and let's just do that real quickly. We've got time. So just going to stat, and I just want to put these numbers in real quickly. Okay, so if I do a histogram there, I go up second function stat plot. I need to turn this on and come down and select the histogram button. And I put my data in L1. Now guys, all I gotta do now is go zoom 9. And I get a bell-shaped and symmetric distribution. Now the reason that line's going through there, if I hit Y equal, I can see that I've got some stuff in there, so I can get rid of that. Hit graph again, and I don't have that annoying line. So I have a bell-shaped and symmetric distribution. And if I go to stat, go over to calc, one variable stats, and look at the descriptives of that, L1, I can see that the mean is 5, and the median is 5. Now, let's come into this data set and add something that we know would be an outlier. Outliers create skewness. Okay? So if we have a skewed distribution, then we're almost guaranteed we're going to have outliers. So if I come into Stat, go to Edit, and I'm going to go all the way to the bottom, so I'm going to go up, and I want to add a 20 to this data set. Now, when I look at my, go zoom 9, and look at my distribution now, that one number, which was an outlier, created a positively skewed distribution. My tail is going to the right. Again, positive numbers are to the right. So that would be a positively skewed distribution. And what I can see here is when I calculate the mean and the median, using my calculator after adding the 20. Now guys, remember, this was 5, and it was 5 when we didn't have the 20. But what happens when we add the 20? Well, you'll see that L1. You'll see that the mean jumped up to 6.5, but you'll see the median remains stable at 5. So guys, what we say there is we say that in the presence of outliers, the median is a more stable measure of center than is the mean. The mean chases outliers. Notice I made a number bigger, right? Well, the mean got bigger, so it chased it. If I had put negative 20 over here, the mean would have got smaller. It would have chased the smaller number, okay? But the median is a more stable measure of center. So guys, long story short, when you have any kind of skewness, positively or negatively skewed, the measure of center that you want to depend on will be the median. And the measure of spread that you want to depend on will be the measure of spread that's built around the choice for center, which is the median. So just as I said before, the measure of spread would be the quartiles. Okay? That's an important thing. I mean, it's really something, one of the important key concepts in Math 1500 that I want you to leave here knowing. Number 2, classify the following distribution as bell-shaped and symmetric, positively or negatively skewed. You guys, when I smooth that thing out, you can see I get a bell-shaped and symmetric distribution. So the correct answer here would be bell-shaped and symmetric. The measure of center that we would depend on would be the mean. And the measure of spread that we would depend on would be the measure of spread that's built around the median. So and ultimately what we do is we choose the measure of center that's appropriate, and then the measure of spread is just the one that goes with our choice for this. So standard deviation is built around the mean. Because guys, if you think about the standard deviation formula that we talked about way back when, what do? Well, our measure of spread, the standard deviation, takes each score and looks at its distance squared from the mean. So we're looking at the distances from the mean squared to actually create the standard deviation. We don't do that with the median. The median, we look at kind of like a box plot or a 5-number summary, and the quartiles are around the median. All right, guys, another problem that you're going to run into, I think we did one of these earlier. We did something more in terms of GPA, but got to get my coffee in me. But anytime you're combining samples, you have to use sums. And I'm going to just briefly go back over that for you because I know it's been a while. But when we start out with the simplest formula for the mean, this just says the mean can be found by taking the sum of the scores divided by how many scores we have n. Well, guys, we can multiply both sides by n, and we can say that the sum of the scores can always be found by taking our sample size times our mean. Now, when we go back to this problem right here, what kind of thing do we get into? Well, sample number 1 has 15 scores, and the mean is 75. I don't know what those 15 scores are, but I know that the sum, and guys, that's nothing, again, it's a kind of a funny looking mathematical symbol for some of you, but the sum is nothing more than just adding up the scores, and we know that this can be found by taking n times x bar. Well, for the first sample, our n is 15, and our mean is 75. Now I'm going to grab my calculator real quick. So 15 times 75 is 1125. I don't know what the scores are, but I know to get a mean of 75 from 15 that they have to add up to 1125, because 1125 divided by 15 gives us 75. Guys, the sum of the second group, and I should put a 1 here and a 2 there to denote sample 1 and sample 2, okay, has 40 scores and a mean is 52. So 40 times 52 is 2080. So the sum of the scores for the second group would be 2080. Now guys, what I can do now is I can get the sum for all. And all I have to do is add the 1125 to the 2080, and I get 3205. But this tells me that I can go back. It's probably going to help you if you can actually see what I'm writing. So the sum for both is 3205. Well, I can go back to the original formula for the mean. It says, because we're trying to find a combined mean, that we can find the mean of a group of scores by taking the sum. Well, the sum for all the scores combined is 3205. And we have 15 in the first, and we have 40 in the second. So I have 55 total people. So 3205 divided by 55 gives me a mean of 58.27. Now, what a lot of people do in this problem, I see this happen quite a bit. So the correct answer is 58.27. Let me write that down. Get organized here. I can't stand that. All right. So what a lot of people will do here is they'll say, well, I got 2 samples, so I'll just take that 75 and I'll add it to that 52 and divide by 2. You can do that if the sample sizes are the same. But when the sample sizes are different, we get into what's called a weighted mean. And this sample right here with 40 has more weight to it than this sample does with 15. So our sample mean is going to be closer to the 52 than it is the 75 if we look at the center between the 75 and 52. It's going to be drawn toward the sample with the biggest sample size because of the weighted mean phenomena. All right, gang, number 4 says find the mean, median, mode, standard deviation, variance, IQR for the data that is presented in the table. All right, let's do that. This is just really all about knowing how to use your calculator, honestly. So let's clear this out. And so let's go second function distribute. I'll tell you what, I'm going to do this. Now in this one, what we want to do is we want to put our x's in L1, our frequencies in L2, like I talked about in a previous video. So the first thing I needed to go up here and highlight that and go clear, enter. That gets rid of the numbers and not the list. So now I'm going to go in and we'll type the x's in L1. So I have 20, 30, 40, and 50. Okay, and then I come over and put the frequencies in L2. Now, so ultimately, gang, what I want to be able to do there is I want to be able to find the mean, median, the mode, the standard deviation, the variance, and the IQR. Now, a lot of these I can find with my calculator. I can find that one directly with my calculator. I can find that one directly with my calculator, and I can find that directly with my calculator. The mode, variance, and IQR, I have to do a little bit of work, but guys, it's a college class. We should be prepared to do a little work. So let's go ahead and get the ones that we can do. Let me see if I can make this a little bit. See if I can make that a little bit clearer. It's kind of fuzzy. Well, anyway, to do a frequency distribution, we still hit stat, and we come over to calc, and we still use one variable stats. Now, a lot of times people will say, well, we got two variables, so I use two variable stats. You don't have two variables. You have one variable. You have the scores that are in X. The other F is a frequency. It's a count. It's not a variable. So I got one variable stats, and what I'll do here is left parentheses, L1, comma, L2. This is the way I tell the calculator that I have my data in L1 and I have my frequencies in L2. Now, those of you with the other operating system, I'll work it in just a second. So I see that my mean is 44.85. I tell you what, the screen is so bad. Can't hardly see it. Standard deviation is 6.80. And the median, I'll have to come on down and take a look at. The median looks like it is 50. All right. Now, let me go over and use the other calculator to work this problem, because that got kind of crazy. So if I go to stat and edit, again, what I want to do is clear out the old stuff. So go up and go clear enter. Much clearer, isn't it? Go up and hit clear enter. All right, so I'm going to put my my data in X and my frequencies in Y. So I have, what, 20, 30, 40, and 50. I don't know if you guys can hear my dog barking or not, but it's annoying. We have 115. In 100. That tells me that my data set, I have 120, I have 15 30s, I have 55 40s, and 100 50s. Okay. Now the way you do the frequency distribution here is you still go to calc one variable stats, but what you do is you tell the calculator that you put your list, your variable in L1, and you put your frequency in L2. And you calculate, and you'll see that you get the same numbers, okay? Now notice your sample size is 171. Now a lot of times students will try to tell me that the sample size is 4 because you have 1, 2, 3, 4 numbers. Well, no, guys, that's not the way it works. You have 120, you have 15 30s, so you know you've got 16 20s and 30s. You got 55 more that are 40s, and you've got 100 more that are 50s. So to say the sample size is 4 just shows me that you don't know what you're doing, that you and I haven't connected, and you need to be taking statistics over again. All right, gang, let's, from this information, another thing we would get would be the IQR. We could get that from the calculator. So let me bring that back up. I'm going to scroll on down. IQR, remember, is Q3 minus Q1. So the Q3 is 50, Q1 is 40, so I think we can all do the mental math there and say that the IQR is 10.00, okay? So that's easy from your calculator too, but you don't have a calculator key that just gives you that. Now the variance, remember, is just the standard deviation squared. So gang, if you just put 6.80 squared in your calculator, you get 46.24. So the variance would be 46.24. Now the mode, your calculator doesn't give you the mode, but what the mode is, it's just the variable that occurs the most. Well, duh, right? If you got a frequency distribution, it doesn't get any better than that, because frequency tells you how many times something occurs. So we know that 50 occurs 100 times, so my mode has to be 50 because it occurred the most because it had the biggest frequency. All right, next question. Would you expect the distribution of household incomes to be bell-shaped and symmetric, positively skewed, or negatively skewed? Guys, anytime you deal with money, you are going to have a positively skewed distribution. The reason being, people like Oprah and Michael Jordan, Bill Gates, Warren Buffett, there's not many of them that make tremendous amounts of money, but they're outliers, and they pull the distribution to the right because, again, there's not many of them, but they certainly aren't in the typical range of scores. So if you just very quickly thought about what would a histogram look like of money, let's just think from $0 to $100,000. Well, there would be a lot of families that make between 0 and 100,000. From 0 to, from 100,000 to 200,000. Yeah, quite a bit, but not nearly as much. In fact, I'd say that probably even a bit lower. How many families make between 200 and 300,000? I'd say very few. How many between 300,000 and 400,000? Even less. And then here's Michael Jordan, and here's Oprah, and there's Warren Buffett, and there's Bill Gates. They're out here in a league of their own. So guys, anyway, because of that reason, you will have a tail that'll go toward the positive numbers. And so rest assured, when you have a distribution that deals with money, you can be guaranteed you're going to have a positively skewed distribution. Almost guaranteed. I can come up with situations where it wouldn't be if you restrict the population. Let's say you're just looking at a neighborhood. Well, people who live in a particular neighborhood are typically, not always, but typically, sorry guys, need some coffee. Typically in kind of the same economic class. And again, not always. Now, estimate the values of the 5-number summary. Well, guys, this is the smallest number. When I drop that down, it looks to me it's about at a 30. Now, this is Q1. When I drop it down, I'm going to say that's approximately a 34. The median is right there. I'm going to give that approximately a 45. This is Q3. I'm going to say that's approximately a, 52, 51. And this, of course, is the biggest number, and I'm going to call that about a 61. So the 5 numbers summary from a box plot is very easy to get. All right, gang, number 7, the distribution of gestation periods for pregnant adult females is normally distributed with the mean of 266 days. Standard deviation 16 days. So those of you that are pregnant, if any, actually I know that one student is pregnant. There you go. That's more than you ever cared to know about the distribution shape, or maybe it's exactly what you wanted to know. Maybe you woke up this morning thinking, if I just knew the distribution of shapes for gestation periods, my life would be so much more complete. And gang, I'm trying to find a piece of paper that I haven't written on. I'm not having any luck. So, all right, so essentially what we're saying with that is we have this normal distribution that has a mean of 266, so it's going to be smack dab in the center. And then again, this place right here where it becomes linear is one standard deviation above the mean. So this will be 282. This will be 250. This will be, I don't like doing this stuff, 298. This will be 234. And usually we go up 3. So add 16 to that, 314. Subtract 16 this way, looks like 218. All right, so that's what the distribution looks like. Approximately 68% of you that are pregnant, your gestation will last between 250 and 282 days. Approximately 95% of those that are pregnant will last, your gestation periods will last between 234 days and 298. Almost everyone, 99.7% of gestation periods will last between 218 days and 314 days. Guys, it's rare to have a gestation period above 314, and it's rare to have a gestation period below 218. All right, so let's answer the problems. So random sample of 50 pregnant adult females is selected at random. What's the probability they're mean? Guys, when you see mean and probability, you know central limit theorem. Okay, so working this problem, we're going to go to normal CDF. And we want what? Greater than 265? Lost my mind there. The mean is 266. And the standard deviation is 16. Since we're doing the standard, doing the central limit theorem, we have to divide out by the square root of the sample size, which is 50. Guys, if you don't divide out by that, you're going to get it wrong. So the answer would be 0.6707. All right, I'll tell you something I think is going to work well here. Let me go split screen on you here. I think that's going to work the best. If I can figure this out. All right, hopefully you can see that. The second says a random sample of 35 pregnant adult females is selected at random. The mean pregnancy duration was 264.5 days. Find and interpret their z-score. So guys, the z-score for this type of problem, as I've shown in previous videos, is the sample mean minus the population mean divided by the standard deviation divided by the square root of n, and all this stuff needs to be in parentheses. So for this particular problem, my sample mean is 264.5. So guys, I'm going to have 264.5 minus the population mean, which is 266, divided by the square root, divided by the population standard deviation, then divided by the square root of the sample size, which is 35. No, gosh, I got to do this differently, don't I? So I got to hit delete, delete, and then I've got to hit my right arrow and then hit my key there. Okay? So a little trick here, but it's cool. So the z-score is negative 0.55. And I'm not going to write this out because I've done it before, but I'll speak it very slowly. We would say a sample mean of 264.5 days for a sample of 35 is 0.55 standard errors below, it's below because it's negative, the mean. So again, a sample mean of 264.5 when taken from 35, of sample of 35, is 0.55 standard errors below the mean. All right, gang, the next one, what mean gestation for n equal 100 pregnant adult females represents the third quartile? Well, guys, what we're trying to do there is we're saying that we've got this distribution. Now, guys, remember, third quartile is 75% below. So we know it's going to be right of the mean because the mean has 50% below. So we need to find the sample mean that has 75% of the distribution to the left of it. Below, left, above, right, those are all equivalent. Well, guys, how do we find a score from a distribution? Well, we use our our inverse norm key. So I need area below, so that's going to be 0.75. Remember, if you're given area above, you still put in area below. The mean is 266. Guys, we're in a standard deviation issue, so what does it say for this problem? 100, okay, so we need 16 divided by the square root of 100. Guys, don't forget to divide by that square root. So the sample mean would be 267.08 days.